Hello guys, I'm Joseph Lyle Solis and today I'm going to talk about algorithms. Our world is full of problems and each problem has many solutions since each one of us has a unique approach on how to solve that problems. So by definition, so an algorithm is a finite sequence of finite steps of computational that will arrive on the result that we want to arrive on. So there are tons of algorithms in computer science, and before we discuss on the some basic algorithms on computer science, let us discuss first the properties. So so I devised mnemonics such that we could be more familiarized with the properties of an algorithm. So the mnemonic goes: I'm on the car. I on the car. Fully efficient gas. So so first property is input. Every algorithm needs an input so that we could use it as a for the computational of the algorithm, so we could arrive on the outcome or the outcome or the output of the algorithm. So the next one is letter D, stands for definiteness. Definiteness. So each step on an algorithm should be well defined so that the reader can comprehend and digest it. So next is correctness. Every algorithm or every step on an algorithm should be logically correct such that the result that we need would be right, not wrong, because due to some logical errors, right? Then the next property is finiteness. So every algorithm should be finite so we could follow through what the algorithm or the steps it takes. And in this case, an algorithm needs to be to have an effectiveness. Why we need effectiveness or efficientness? Because an algorithm should be able to do the solution in a short span of time. We do not want an algorithm to take about a year, a century, a decade, or even a millennium. Why would we even want an algorithm that takes years to finish, right? Then next one is generality, or the last property. So an algorithm should not be only for a specific data set. If we change the values of the data set, the algorithm should be able to perform the solution still on that data set, even if it is changed. So now, so let's dive with the algorithms. In computer science, there are tons of algorithms, as said a while ago, and the basic ones are searching, sorting, matching, and Greedy's algorithm. I'll be discussing sorting, matching, and Greedy's algorithm today. So let's start with bubble sort, the most common sorting in sorting. So bubble sort. Say we have an example of sorry, 6, 5, and 7, and 3. So let's discuss the steps first. So the input here is that the array should be have an element greater than or equal to 2. We do not want an array of only having one element, since why would we even sort a single element, right? So the output here is the sorted elements. So the first loop here is from I1. So we set from I1 the first index to the last index. So no, to the before the last index, which is n minus 1. To the second loop, j equals to 1 to n minus I. Why n minus I? N minus I stands for creating a division line for the sorted and unsorted elements. So here we compare each time in that loop if that current element is greater than the next element, then we interchange them. So let's start with this problem. So we have here 6 and 5. So let's start with comparing 6 and 5. So since 6 and 5 are, since 6 is greater than 5, we interchange them, right? Then we compare 6 with 7 since it is in the current position of 5. So since 6 is less than 7, we do not interchange. Then 7 is compared to 3. Since 7 is greater than 3, then we interchange them. So the current list here is 5, 6, 3, and 7. So here comes n minus I. Since we know that 7 is already the max here, so we create a division line here. So that is n minus I. Then let's start the loop again. So we compare 5 and 6. Since 5 is less than 6, we do not interchange them. Then next, we compare 6 and 3. Since 6 is greater than 3, we interchange them. So that ends the loop again. So we have the current state as 3, 5, 3, 6, and 7. So the division line now lies here. So this means this is the sorted one, this is the unsorted one. So we compare 5 and 3. Since 5 is greater than 3, we interchange them. So since we are already in the division line, we end the loop again. So here is the finished product. 3, 5, 6, and 7. There you have it. We have a sorted array. 3, 5, 6, 7 from 6, 5, 7, 3. So now let's erase them. So by the way, sorting is very important in sorting data, since in a directory we need to sort the addresses of each residence, the numbers. So sorting is very important. So next is the string sorting, so string matching rather. So in real life situations, string patterns are very important, especially in the field of genetics. When we look at DNAs, we look on the patterns that we need for. Say we need the pattern CAG in the DNA pattern of something. Then here, in this problem, I gathered the example from the book. So here is the example. So here, in this case, we are finding for the word letter I. So letter P here stands for the word we are looking for, which is this, the I. This is the string P. Then T is the word that we will use to find I, and I is the letter P, which is the stands for pattern. So the first loop is from S0 to n minus m. N is the largest index on the word we are using to find the pattern I. Why minus m? Because m is the largest index on the pattern we are looking for. So we end the loop before we reach So we allot a space on the m, on the x, on the number of indexes on the pattern, on the word we are looking on. We are looking on the pattern of the pattern. Sorry for that. So here we set j as 1 again. Over and over again we set j as 1. So j not less than, on the while loop, not less than or equal to m, which is the index of the pattern we are looking for. And t s plus j is what? S plus j is the current we are looking for. So the letter we are placed now, then we compare it to the letter of the pattern we are looking for. Then if it satisfies the while loop, we increment j plus 1 and we compare again if it is the next character is equal to the next character of the pattern. And if we keep on satisfying this while loop, and if we arrive that j is greater than m, then it is a valid shift. So here in this problem, let's start with the letter here is ECE Yeye. So in the first letter, we know that E is equal to the first character of the pattern, but the next character is not equal, which is C. C is not equal to Y. Then we move directly on to the next shift, which is 1. Then we know that C is not equal to E. Then we know that the pattern could not be scanned there. So we move next to the next shift, which is shift 2. So E is equal to the first character of the pattern, then Y is also equal, and E is also equal, which makes this shift a valid. So this shift is valid. Then next is Y. Y is not equal to the first character, which is E. So we move to the next. Then next is E. Next shift is E. So equals to the first character, and the next character is equal to the next character, and the next character is equal to the next character, which is I. Then which makes for the shift 4 as valid. So that's how shifting basically works. So let's move to the greatest algorithm. So in greatest algorithm, I'm gonna use the basic example Cashier's algorithm. So greatest algorithm is all about in solving optimization problems. In real life, we always wanted to find the best for us. While in shopping in supermarkets, we find the cheapest price so that it will suit our budget. So that's how greatest algorithm work, right? So in this Cashier's algorithm, say we have denominations 25, 10, 5, and 1. So we have an example of what? 97 cents. So 97 is divisible by first 25. When we divide it, we have a quotient of 3. So we have 3. So the remainder here is 22. So next, so we x this. Then we divide 22 by 10. Since its quotient is 2, we add to the total denomination as 2. Then we have a remainder next of 2. Since it is not divisible by 5, we cross this, and the last one is 1. Then we divide it by 1. We have a remainder of 0 and a quotient of 2. So the total denomination here is 7. So that's how Greedy's algorithm work. We find the best for the current problem, best solution. So hope you guys enjoyed this video. This is Joseph Lyle Solis signing off for today.